Hello guys, welcome on Tesla Adventures. In this video, we are discussing the solutions for the first test of Mechanics 1 in this exclusive test series for JEE Advanced 2024. So you know the syllabus, and starting from the question number 1, you can see that there is a cyclist which is moving on a bridge across a river, and there is a boat which is rowed in the river, and both cyclist and boat start at the same instant and from the same point, and cyclist is moving on the bridge and boat is floating in the river, and they both reach the point A simultaneously. Now there is a person which is floating on a raft in the river, and he observes that both cyclist and boat are moving at an angle of 127 degree from the flow, and they both cross the river in 10 seconds, and the width of the river is 40 meter. So we have to mark the correct statements. Now we know that the absolute velocity of the cyclist would be only along the bridge, because it is moving along the bridge. Therefore, let's suppose that the velocity of cyclist Vc is the velocity of cyclist with respect to ground. So this velocity Vc would be equal to 40 by 10, which is 4 meters per second, because the cyclist has crossed this river which is 40 meter wide in 10 seconds. And same is with the boat. That boat has also crossed the river in 10 seconds. Therefore, it's the net speed of the boat. Let's suppose this is the speed of the boat with respect to river, and this is the component of the boat. So this angle, total angle, is 127. So this is 37, and this component of the boat will be equal to VB cos 37, and VB cos 37 will be again equal to 4. Now cos 37 is cos 37 is 4 by 5, so VB is equal to 5. So the speed of cyclist is 4, speed of the boat relative to the water is 5, and obviously this is the speed of the river. So if we have to find out the speed of the river, we can say that this river is flowing in such a way. See, you know that cyclist is moving only along this path on the bridge, but this is with respect to ground, but with respect to the river, cyclist is moving like that with some other velocity. This is with respect to river, because the velocity of river would also be added in this velocity, and this would be the case. So this angle is also 37. So we can say that tan 37, this is tan 37, will be equal to this velocity, which is VR, by Vc, and tan 37 is 3 by 4. So VR will be equal to 3 by 4 of Vc, and therefore we can say that VR is equal to 3. So the correct answers are B, C and D. I would be presenting the answer key at the end of this video, so you would be getting that answer key. Now we move on the next question. In this question, you can see that there are two monkeys, 1 and 2, and the mass of both monkeys is 1 kg, and they are hanging on the string, and there is a block of mass 2 kg which is at rest in the situation shown, and it is also given that this monkey is just holding up the string. It is not trying to move up or move down with respect to the string. In fact, he is just holding up the string. Then which of the following option is correct, are correct in fact. So first of all, we use the condition that the block of mass 2 kg is at rest. So if this block is at rest, then we can say that if this tension is, let's suppose, T, and this tension is T, so T will be equal to 20 first of all. Okay, now the mass of this monkey is equal to 1 kg and the tension T, which is 20 Newton, is acting on this monkey. So the net force on this monkey would be T minus mg, and this is ma, and this is monkey 2, so ma2. So this is 10 and it is equal to 1 into a2. So a2 will be equal to 10. So the acceleration of the monkey 2 will be 10 in the upward direction, and the acceleration of monkey 1. So you know that this tension would be 2t, and therefore it would be 2t, and 2t is 40. So for monkey 1, 40 is force which is acting in the upward direction, and this monkey is experiencing mg in the downward direction, which is 10, and this is equal to 1 into a1. So a1 will be equal to 30. So the acceleration of monkey 1 is 30, and the acceleration of monkey 1 with respect to rope. Now we know that if this block is going nowhere, the acceleration of this block is 0. Let us redraw the situation. The acceleration of this block is 0, and the acceleration of this monkey is 10 in the upward direction. This is 10. So the pulley would be moving in the upward direction with the acceleration of 5, which is obtained by using the average method, 0 plus 10 by 2. And therefore this rope would be moving in the downward direction with acceleration of 5. So acceleration of 1 with respect to rope will be equal to 30 minus of minus 5, which is 35. So the acceleration of monkey 1 with respect to rope is 35, and the acceleration of monkey 2 with respect to rope is 50. Let us examine this. So this rope and this monkey is not moving relatively, because it is given that monkey 2 is just holding up the rope, which means he is not trying to move up or down with respect to rope. Therefore his acceleration with respect to rope would be 0. So this is incorrect. So the correct answers are A, B and C. Now we move on the next question. In this question you can see that there is an ant which is scampering. Now scampering means moving with the short steps very fast. Okay, so this is scampering, and it is moving on a paper with a velocity of 10 meters per second. Okay, now suddenly this paper starts to move along the x-axis with a velocity of 10 meters per second, and the coordinate system has an origin which is fixed at this point. So initially ant was at origin. Now we have to choose the correct alternatives. The velocity of ant in the ground frame is 18 I cap plus 6 j cap. Let us examine the situation. We know that velocity of ant with respect to paper. So with respect to paper, this is 10. This angle is 37 degree. So this component is 10 cos 37, which is equal to 8, and this component is 10 sin 37, which is equal to 6. So the velocity of paper is also 10 in the x-axis. Therefore velocity of this ant in the ground frame would be 10 plus 8 I cap plus 6 j cap. So option A is correct. Position vector of ant with respect to ground in 3 seconds would be, obviously if velocity is this with respect to ground and you have to find out the position vector of ant in 3 seconds, we can multiply directly these two. So it would be 18 into 3, which is 54, plus 6 into 3, which is 18. So the correct answer is B also. In the ground frame, the velocity vector of ant makes an angle which is less than 37 degrees. So let us examine this one. So in ground frame, you can see that this velocity of the ant is 18 and this one is 6. And if we find out this angle with respect to the ground, the angle of velocity with respect to the ground, then this theta, tan theta, is equal to, this is 6 by 18, which is 1 by 3. And obviously this angle is less than 37. Or you can also imagine the fact that in the ground frame, the x component of the ant has increased from 8 to 18, and the y component remained the same. So if this component increases, then this resultant velocity vector would bend towards this increasing component. So the angle would be less than 37 degree. So the correct answer of this question would be A, B and C. Now we move on the next question. In this question, you can see that there is a rod and there is an ant which is moving on the rod. So let us draw a rod. This is a rod and this is hinged from this point, and this rod is rotating with a angular velocity of omega, which is constant also in anti-clockwise sense, and an ant which is crawling on the rod is crawling with a uniform speed of u with respect to the rod, like that. So at any other time, if we can draw the diagram, that at some other time this would be the situation. This angle theta would be equal to omega t, and if let us locate the ant, that ant is somewhere here, then this distance is r. R will be obviously equal to ut, and this component would be r cos omega t, and this would be r sin omega t. Okay, so the position vector of this ant would be ut cos omega t I cap plus ut sin omega t j cap, which is option A. Now the speed of ant at any time t is, now we know that ant is moving with the speed of u like that and with the speed of r omega like that, because ant is on the rod and rod is this point of the rod is moving with the speed of this r omega like that. So the net speed would be under root of r square omega square plus u square, where r is ut, so v net will be equal to under root u square t square omega square plus u square. So we can take common u square, so the correct answer would be B. And the magnitude of tangential acceleration would be at. It is dv by dt, the rate of change of speed. So if we differentiate this one, then C would also be the correct answer, and D is obviously wrong. So the correct answers are A, B and C. Now we move on the next question. In this question, you can see that there is a rod which is clamped between two walls, and there is a ring of mass m1. This ring is constrained to move on this horizontal rod, and there is a smooth wire which is connected with the ring, and from the other end this wire is connected to the ball of mass m2. This angle is constant throughout, and this angle is theta. So first of all, let us see that we know that this tan theta would be equal to, this is m2a and this is m2g. So tan theta would be a by g, and this is t and this is also t. So the y component of t would be t cos theta, which would be balancing out m to g, and t sin theta would be balancing out m to a. And the net force by this rod on the ring is n normal reaction, and this normal reaction would be m1g plus t cos theta. So n would be equal to m1 plus m2g. So option 1 is incorrect, because it says that force on m1 by wire is less than m1 plus m2g. Okay, so net force on m2. So now acceleration a of c. You can imagine from the ground frame that these ring and this ball would be moving along x-axis with the same acceleration a, and no one would be moving in the y direction. So the acceleration a would be equal to net force upon the total mass of the system, which is m1 plus m2. Okay, and this is the acceleration, and the net force on this ball would be ma, and m is m2 and a is this. So F net on the ball would be equal to m2f upon m1 plus m2. So B is correct. The tension in the rod is m2g sec theta. You can say that tension is m2g sec theta. It is also correct. And F will be equal to m1 plus m2g tan theta. You know that from this equation A is equal to g tan theta, and F will be equal to this is F is equal to m1 plus m2a, which is g tan theta. So option D is also correct. So the correct answers are B, C and D. Now we move on the next question. In this question, you can see that there is a spring whose spring constant is mg by L, and there is a ball of mass m which is connected to the thread which is connected to the spring from the other end. Initially, spring was in the relaxed position, which means it was not extended, and the ball is released, obviously, because when the ball would be in this position initially, then this string would be relaxed and the tension in the string would be 0, and therefore this spring would also be relaxed. So we can say that if the ball is released from this point, then the ball first goes to this point, then it moves L by 2, and then also it moves L by 2, then it starts to pull this string. So the ball moves L by 2 and L by 2, which is L, and till this point the tension is 0. Now again, if the ball starts to descend down more, then a point will come when the spring force would be balancing out the mg of the ball. Till that point, ball is accelerated. So the maximum velocity of the ball would be attained when the spring would be balancing its mg. So mg of the ball would be equal to kx, and x would be mg by k. Now k is mg by L, so x would be L. So when the ball would move down by a distance x from this position, so let us see that this is L and this is x. So ball has descended down by a distance of x, then the velocity of the ball would be maximum. So in this position, you can see the work done by mg on the ball would be mg into 2L, because ball has moved by a total distance of 2L, and the spring energy stored in the spring would be half k, which is mg by L, into x square. X square is L square. So U is mg L by 2. This is energy stored in the spring. Okay, and the rest of the energy, which is mg into 2L minus mg L by 2, is in the form of the kinetic energy of the ball, which is half mv square. This is V max. So 3 by 2 mgl is equal to 1 by 2 mv max square, and V max is equal to under root of 3gl. So the correct answer is A. Now the maximum velocity of the mass m during the fall. So let us see that this is obviously A is correct, B is incorrect. The maximum potential energy is stored in the spring. Now you can easily imagine that at the moment when the ball would be at rest, then the spring would be maximum stretched. And at that moment the energy stored in the spring would be maximum. So we can say that at that moment work done by mg would be equal to mg into L plus x. Let's suppose that maximum extension is x, and the spring has also been stretched by x. So the energy stored in the spring would be U is equal to half kx square, and there is no kinetic energy because ball is at rest at the in that situation. So work done by mg would be equal to energy stored in the spring. So mg L plus x would be equal to half k, which is mg by L into x square, and cancelling this mg with mg. So this is 2L into L plus x is equal to x square. So this is x square minus 2lx minus 2l square is equal to 0. And this x would be equal to plus 2l plus minus under root 4l square plus 8l square by 2. So you can see that this is obviously we would ignore this negative because x could not be negative. So cancelling 2 with 2, this is L plus L root 3 by this. So x would be equal to L common 1 plus root 3. Now energy stored in the spring is half k, which is mg by L, and this is x square. So U max will be equal to half mg by L into x square is L square into this is 1 plus 3 plus 2 root 3. So this is mgl, and it would be 2 plus root 3. So the correct answer would be C. So the correct answers of this question is A and C. Now we move on the next question. In this question, you can see that there is a man who can swim in the still water with a speed of 3 meters per second, and this x and y are the axes with respect to ground. Now the river is flowing with a speed of 2 meters per second, and this man starts swimming from origin at t is equal to 0 seconds. Assuming that the size of the man is negligible, we have to find out the locus of all those points where this man can reach at t is equal to 2 seconds. And in fact, this is the locus. We have to find out the value of AC by 4. So let us analyze the situation. Let us see that, let us suppose that this man moves with a speed of v at some angle like that, theta. So this is obviously v is equal to 3, and this is the velocity of the man with respect to river. Now with respect to ground, v velocity of man in x direction is v sine theta plus velocity of river, which is 2. And the x coordinate, x would be equal to vx into t. So x would be equal to v sine theta, which is v is 3, so this is 3 sine theta plus 2 into t. And in y direction, vy is v cos theta, which is 3 cos theta, and this would be equal to y by t. So y will be equal to 3 cos theta into t. This is y. Now what we have to do, that we have to find out the relation between x and y, and we have to eliminate theta. So the best way to do this is, first of all, let us substitute the value of time. T is equal to 2 seconds, and let us find out the value of sine theta from the equation number 1. So you can see that x by 2 minus 2 is equal to 3 sine theta, and 3 cos theta is equal to y by 2. So this is squaring and adding, so it would be, this is x minus 4 by 2 is equal to 3 sine theta, and this is equation 2 and this is 1. 1 square plus 2 square would be equal to 9 sine square theta plus cos square, which is 1. Obviously we can write it down as 1. So 1 is equal to y square by 4 plus x minus 4 whole square by 4. Okay, so you can see this. Now the value of this is y square plus x minus 4 whole square is equal to 36, and therefore you can see that a is equal to 4 and this c is equal to 6. So the value of AC by 4 is AC by 4 is equal to 6. So the correct answer is 6. Now we move on the next question. In this question, you can see that there are two objects of masses m and m, same, then they are connected with a rope of length L. L is equal to 0.3, and the mass of the rope is also m. Initially the situation is shown in the figure, and this system is released from rest, and we have to find out the speed of A and B at the time when the B descends down by a distance of L by 3. So you can see that what we have to do, we have to find out delta U of the system. So you can see that this block descends down by a length of L by 3. So delta U is mg L by 3. Okay, and I am just calculating the magnitude. I know that the potential energy is decreased, but I am just calculating the magnitude. We can say that this is work done by mg on this block B, as well as the fact that the initial potential energy of this rope, U initial of rope, hanging rope, is equal to m by 3 g L by 6, and U final of hanging rope will be equal to m by 2m by 3, because finally 2L by 3 length of the rope will be hanging into G, and the length of the rope would be 2L by 3. So its center of mass would be at a height of at a depth of L by 3. So this is L by 3. So delta U of rope will be equal to U initial minus U final. So this is mgl by, mgl is common, 1 by 18 minus 2 by 9. So this is negative of mgl by 6, and if we find out the magnitude of delta U, then it would be mgl by 6. So total delta U will be equal to, this is of B, this is mgl by 3 plus mgl by 6. So it would be this is 3 by 6 mgl. So this is mgl by 2, and it would be equal to half of mv square. Now we know that in this situation, when these block and this rope would be moving, then all of them would be moving with the same speed, and therefore we can use the value of mass as 3m, and v square. So v will be equal to under root of gl by 3, and it would be g is 10, l is 0.3, and this is 3, so it would be 1. So the value of v finally would be 1. Now we move on the next question. In this question you can see that there is a sleeve of mass 2 kg which is at origin, and this sleeve can move on this parabolic wire shape which is having an equation of x square is equal to 4y. There are two forces which are constant forces. F1 is 6 Newton and F2 is 8 Newton. These are constant in magnitude as well as in direction, and these are displaced. This sleeve is displaced from origin to x is equal to 4. So we have to find out the net work done by F1 and F2. Now we know that the work done by these forces is obviously the work done can be calculated by directly multiplying the forces with the displacement, but we have to remember one thing, that the forces are in x as well as y direction. So the net force in x direction, if we write down, this is Fx. So the net force in x direction would be F1 plus F2 cos 30. Now Fx is equal to F1 which is 6 plus F2 which is 8, and cos 30 is root 3 by 2. So the net force in x direction will be, this is 6 plus 4 root 3, and the displacement from origin to x is equal to 4, so the displacement in x is also 4. So work done by Fx will be equal to 6 plus 4 root 3 into 4. So this would be 24 plus 16 root 3. Now Fy will be equal to F2 sin 30, and we know that F2 is equal to 8 Newton, so this is 8 into 1 by 2, so this is 4. So work done by Fy will be equal to 4 into displacement. Now displacement of y direction can be calculated as the y coordinate when x is equal to 4. So when x is equal to 4, we can see that y is also equal to 4. So work done by Fy will be equal to 4 into 4, which is 16. So the net work done would be sum of these two work dones, and this would be 40 plus 16 root 3, which would be approximately 67.68 joules. So this is the correct answer. Now we move on the next question. In this question you can see that there are two trains A and B which are moving on a straight track towards each other. At t is equal to 0, the situation is shown, and the train driver of B realizes that in order to avoid the collision, this B train must fit into the side track. The length of the side track is exactly equal to the length of the train B, and the length of train A is very large as compared to the length of the side track. So it cannot be fitted in this track. So A continues to move with the same speed of 4 meters per second, and we have to find out the minimum magnitude of deceleration of train B so that the collision is avoided. So let us analyze the situation. We know that if train A is traveling with constant speed of 4 meters per second, then the engine of train A would take 25 seconds to move from this point to this point, because it has to cover a distance of 100 meters with 4 meters per second. So the time taken by this train A would be 100 by 4, so it would be 25 seconds. Now Now in this 25 second, this train B has to cover this distance 100 meter, and in fact we have to find out the minimum deceleration. So we are just assuming that this train B just stops after covering this 100 meter. So let us assume that the final speed of the train B is 0. So V square is equal to U square plus 2AS. So 0 is equal to VB square, and VB is not mentioned in the question. Nevertheless, we can find out the VB. So VB square minus 2 into A, which is retardation, into S is 100. So VB square is equal to 200 A. This is the first equation. Now the second equation will be coming from VB is equal to UB plus AT. So VB is 0, UB is VB, and A is minus A into T. Now time is 25. So we can substitute the value of VB here. So VB in this case would be equal to 25A. So 625A square is equal to 200A. Cancelling this A with A, this A is equal to 200 by 625. So we can see that it is 8 upon 25, and therefore this alpha is equal to 8. So the correct answer is 8. Now we move on the next question. In this question you can see that this is a L-shaped sheet or bracket, and this bracket is being pulled on a smooth floor by a constant horizontal force of 6 newtons. There is a block which is initially kept on this bracket, and it is touching both the wall and the floor, and the floor, which is the horizontal surface of the bracket, is smooth while the wall is rough, and the coefficient of friction of wall is 0.5, and this block is being given an initial velocity of 5 meters per second. Its mass is 1 kg and the mass of this bracket is 5 kg. We have to find out the time in which this block will stop with respect to this bracket. So first of all, we know that in this direction, in x direction, the acceleration of the system can be calculated by F is equal to m plus ma, because they both are accelerating along the x-axis, and F is 6 Newton and capital M is 5 and small m is 1, so this is 6a. So a is equal to 1 first of all. So this is the acceleration, and this block is experiencing a friction force, and the normal reaction N acting on this block by the wall would be equal to ma, and obviously m is 1 and a is 1, so it is 1, and friction would be mu into n. So friction would be half, because mu is half, and F would be equal to ma, where a is the retardation of the block and m is 1, so a will be half. So this block would be retarding with a retardation of half meters per second square. Now this block is initially moving with a velocity of 5 meters per second, and we have to find out the time in which it would be coming to rest with respect to the bracket. So we can say that V is equal to U plus AT, and V is 0 and U is 5 and A is half, and T is the time in which it stops. So this is 10, and we have to find out the value of 0.6t. So 0.6t will be equal to 6. So the correct answer is 6. Now we move on the next question. In this question you can see that there is a tank which is at a perpendicular distance of 360 meters from this line, and this is the enemy tank, and this is the artillery gun which is installed, and it can only fire in ZY plane like that. This enemy tank is moving towards this A with a speed of 9 meters per second along this direction TA, and this gun is fired with a speed of 100 meters per second at an angle of 53 in such a way such that it lands at this point A. If this tank started at t is equal to 0, then the time interval after which this shell should be fired so that it hits the tank. So now first of all, let us find out the distance TA. So we can see this point B, this distance, this is 360. So let us suppose that AT cos 37 is equal to 360. So AT cos 37 is 4 by 5. This is 360. So AT will be equal to 450. And this distance AT is 450, and the time taken by the tank to reach with a speed of 9 meters per second would be 450 upon 9. So it would be 50 seconds. And the time of flight of this gun T2 will be equal to 2u sine theta by g. So T will be equal to 2 into u is 100 sine 53 divided by 10, and T will be equal to 2 into 20 into sine 53. Sine 53 is 4 by 5. So it would be 16. So the time difference is 50 minus 16, which is 34 seconds. So this artillery gun should be fired after 34 seconds of the time when tank started to move. So the correct answer is 34. Now we move on the next question. In this question, you can see that we have to match the column, and it is a potential energy of a system is given. This system is a diatomic molecule which has two atoms which are at a separation of r. So first of all, let us analyze the potential energy, that U is equal to minus of A by r to the power 6 plus B by r to the power 12. So F is equal to minus of du by dr. So it would be minus of minus A, and this is plus 6 into r to the power 7, and it would be minus 12b into divided by r to the power 13. Okay, so let us equate this to 0. So 6a upon 6a is equal to 12b upon r to the power 6. So r to the power 6 is equal to 2b by a. So r is equal to 2b by a to the power 1 by 6. So let us first of all analyze option A. So option A says that for r less than 2b by a, force is negative, force is positive, potential energy is minimum and maximum. So we know that potential energy extremes are existing at this point where its derivative is 0. So R and S would not be the options, and you can see all four options that we have to select the option P or Q for A. So we can say that if we substitute the value of the force is becoming 0 at this point, you can see. So if we substitute the value b by a to the power 6 in this equation, so let us see that if we substitute the value u, we know that f is equal to minus 6a by r to the power 7 and plus 12b by r to the power 13. This is f. Okay, so we can substitute the value of r, which is 2b by a, की power 1 by 6. Now we are substituting the value b by a to the power 1 by 6 in this equation. So if we substitute this value b by a, so f would be equal to minus of 6a upon r की power 6 is b by a, so this is b by a and this is r, and plus this is 12b upon this is b upon a whole square and into r. So taking out 1 upon r common, so it would be minus of 6a square by b plus 12 a square by b. So this is 1 by r and this is plus 12b, in fact this is 6b in a square by b. So f is greater than 0 obviously, for r is less than 2b by a to the power 1 by 6. So a will have the correct option q. So we have eliminated fourth and third option. Now we do not need to check for B option because it is same in these both options. Now we can check for option C. Now at this point where f is 0, you can see that this P and Q cannot exist. We have to just choose between R and S. So let us see that these are two molecules in a diatomic atom, and we see that this is the equilibrium position. So for a distance which is less than the equilibrium position, the force is positive. We have already checked for option A, which means that force is repulsive. This is repulsive. And for a distance which is greater than R0, this force is attractive. So which clearly means that the potential energy is minimum at R is equal to 2b by a to the power 1 by 6. So the correct option for C is R. So the correct answer is second. Now we move on the next question. In this question you can see that these two blocks are kept over each other, and the coefficient of friction between 1 and 2 kg block is 0.4 and between 2 kg and the ground is 0.6. And as it is shown in the diagram that these are moving in the opposite directions, therefore friction acting between them would be kinetic, and therefore we can easily say that the friction force acting on the 1 kg block would be in the backward direction, and it would be equal to 0.4 into 10, so it would be 4 Newton, and the friction force acting on this 2 kg block would be in forward direction, and it would be again 4 Newton, but the friction acting of the ground would be of 0.6 into 30, so it is 18 Newton. So the acceleration of or we can say the retardation of 2 kg will be, this is 22 by 2, which is 11, and it is in the backward direction or forward direction, and the retardation of this 1 kg block will be 4 by 1, which is 4 in the forward direction. So we have to check the option D. So we can see the absolute acceleration of 1 kg block, it is 4, so P is incorrect, so this option is eliminated. Absolute acceleration of 2 kg is 11, so Q option is also eliminated. Relative acceleration of the two blocks is obviously 15, so the correct option for D is R, and the net force acting on the 2 kg will be 2A. Net force is equal to MA, so net force is 2A, so it is 22. So the correct answer of D is R, and therefore we can directly say that the correct option is D. Now we move on the next question. In this question, you can see that there is a particle which is performing rectilinear motion on x-axis in such a way such that its x coordinate varies with the time as this equation, and this x is its x coordinate and t is the time. We have to match the correct options. So let us first of all analyze the options. That there are 4 options in which P option has this 4 and 4, this is 2 and 2, and this Q option has 3, 3, 3, 3 in all of them. So Q option will be having the correct matching of 3. R option is 2, 1, 1, 4. So we can just first of all check for P option whether it has 4 or 2 as the correct match. So first of all, we know that this x is equal to, let us use the blank page, this x is equal to t cube by 3 minus 2t square plus 3t plus 5. So this is t cube by 3 minus 2t square plus 3t plus 5, and v will be equal to, this is t square minus 4t plus 3. And if we equate this v to 0, then we can see that t will be equal to plus 4 plus minus under root 16 minus 12 by 2. So t will be equal to 4 plus minus 2 by 2. So there are 2 times. So one time is t1 is equal to 3 seconds, and t2 is equal to this is 1 second. So velocity is 0 at 1 second as well as at 3 seconds. Now let us analyze that now first of all, let us also write down the acceleration. So acceleration is 2t minus 4. Now let us analyze that when acceleration is 0, a is equal to 2 seconds, and at t is equal to 0, you can see that, or we can directly find out at t is equal to half seconds, t is equal to 1 by 2, v is equal to 1 by 4 minus 4 by 2 plus 3. So v is equal to 1 by 4 minus 2 plus 3. So v is equal to 1 by 4 minus 1, in fact plus 1. So it would be 5 by 4, which is positive. And a would be, this is 2 into 1 by 2 minus 4. So this is minus 3. So a is negative. So we can say that at half second v is positive and a is negative. So v is greater than 0 and a is less than 0. So the correct matching for option number P is 4. So these 2 options are incorrect. Now we can match option R, and we would be getting the correct one. So option R says that 5 by 2 seconds. So you can see that now v at 5 by 2 seconds, t is equal to 5 by 2 seconds, v is equal to 25 by 4 minus, this is 4 into 5 by 2, and this is plus 3. So v is 25 by 4 minus, this is 10 plus 3. So v is equal to 25 by 4 minus 7. So it is, v is minus 3 by 4, and a is 2t minus 4. So at t is equal to 5 by 2 seconds, a is equal to 2 into t, which is 5 by 2 minus 4. So it is equal to plus 1. So v is negative and a is positive, which means that option R has v negative and a positive, which is matching 2. So the correct answer would be option number A. Okay, now we can also match the option S to be very specifically correct. So at t is equal to 4 seconds, at t is equal to 4 seconds, v will be equal to, you can see that v is this one, t square minus 4t plus 3. So this is 16 minus 16 plus 3. So v is plus 3, and a is, this is 2t minus 4. So 2 into 4 minus 4. This is plus 4. So a is also positive and v is also positive. So the correct matching for option S is also 1. So the correct match for this one is A, option A. Okay, now we move on the next question. In this question, you can see that one end of this rope is connected with a point mass of mass m, and the other end is being hinged to a fixed point O. This ball can move in a circle, and at the lowest point it is given a velocity v. So we have to find out the correct matching. We can now easily see that option 1 has all different matchings in all 4 options. So we just need to check the option 1. So if we give a velocity of under root gl, then we know that the minimum velocity required to complete the circle is root 5 gl, and the minimum velocity required by the ball at lower point to just reach the point B is under root 2 gl. So this is even less than under root 2 gl, which leads us to the conclusion that this ball will never touch this point and it would leave the circular path before point B. So we can say that this is wrong. This is not the correct option. This is also, speed at b is root 2 gl is not correct. Speed at b is 0 because it would not touch the B point, so we cannot say that this is correct. And the particle completes circular motion, this is absolutely incorrect, and the particle does not complete circular motion. So the correct matching for this one is option number, this one, T. So the correct answer is B. Now we move on the next question.